Sarah Squared. Today we're going to be teaching you about the area and volume between curves. This is a fairly simple process since you will be using your knowledge of integrals and taking it a step further. To start off, we're going to review what the formula for area is. Alright. So, area is equal to the integral from a to b of the function. So this is basically finding the area under the curve. This is the curve, and this is your integral from a to b. And we need to find the area under this curve from 0 to 3. And that's basically this part right here. What you would need to do is write the integral of a equals the integral from 0 to 3 of x squared dx. Alright, so you would need to antiderive it and use the fundamental theorem of calculus. So you would do from x cubed over 3 from 0 to 3. And you would do 27 over 3 minus 0 over 3, and that equals.
Okay, now that you can find the area under a single curve, you can now learn how to find the area between two curves. In this process, you're going to take two functions and subtract either the top minus the bottom function or the right minus the left function. And here's an example of the top minus the bottom function. You're going to take x squared, and you're going to take negative x squared plus 2, which is going to be 1, 2, it's just upside down. You're going to be trying to find this area right here. And this is going to be top minus bottom. So this right now is going to be the top function, and this is going to be the bottom function. So the top function for this one is going to be, and this is going to be from, excuse me, negative 1 to 1, because that's when the two functions intersect. So negative 1 to 1. And it's going to be negative x squared plus 2 as your top function minus x squared dx. Alright, so basically all I did was I took this formula and I simplified it right here to a single function. And then I anti-differentiated it and I made it one function right here from negative 1 to 1. And then this is the function from the 1 when you plug in 1 for the function, and then you subtract the negative 1 function and you get negative 4/3 plus 4 is my answer.
Okay, so you've learned how to do top minus bottom, but sometimes you'll have to do right minus left. And that's like with these curves. You have plus or minus square root of x and plus or minus square root of x minus 2. In order to do these, you will have to write it in terms of y. You basically write the function and you convert it to terms of x, terms of y. And you would get this x for that one, and for this one, you would get that right, and this function should be y squared plus 2. Okay, so once you've got it in terms of y, you can write your integral. So it would be a equals from negative 1 to 1, because that's where they intersect, of y squared plus 2 minus y squared dy. Alright, so this takes you through the process of finding the area using right minus left over the integral and then simplified, and then you anti-differentiate and you plug in the numbers and the area is 4.
You can also also use integrals to find the volume of solids by taking a function and rotating it around a line or an axis. And you can also do this with multiple functions. But at first, we're going to use a simple example like this, which is what the function is x, the square root of x, and we're going to be rotating it around the x-axis. And it's going to form a solid. And we're also going to stop this problem at x equals 3. So this is like the line that cuts it off. And the way we're going to set this up is whenever you make a solid out of this, it's going to have little discs that are all spheres. And the formula to find the volume of a circle is pi r squared. So we're basically going to be taking this formula and putting it into an integral. And the integral, you're going to have to set it up like this from 0 to 3. You know you're going to use pi in the function, so you're going to go ahead and bring pi outside. And then the radius is going to be the function value, which is x squared. And then you're going to square that, so square root of x squared dx. And then when you simplify that, it's just the integral. Same thing, except for the square root of x squared is x dx. And then you anti-differentiate that, and it's going to be x squared over 2 times pi from 0 to 3. And then when you plug in the numbers, you're going to get 8 pi over 2, which simplifies to be 4 pi. So the area of this solid from 0 to 3 is 4 pi. And also, this is pretty much the same thing, except for like the top minus bottom, right minus left. You're going to be flipping this up to where you're going to be rotating it around, like say a y-axis or something vertical instead of horizontal. And you're going to have to do the same thing where you change the function value instead of terms of y equals and x equals. And for this example, we're going to be using the parent function y equals x squared, and we're going to be rotating it around the y-axis and stopping it at y equals 9. And to change this function y equals x squared, it's going to be the same thing as x equals square root of y. And to set it up, we're going to have to do the same process for pi r squared, plugging it into the integral. And it's going to be pi multiplied by the integral from 0 to 9 of the square root of y squared dy. And when you simplify that, it's going to be pi times the integral from 0 to 9 y dy. And then when you anti-differentiate this, it's going to be y squared over 2 times pi from 0 to 9. And when you plug in 9, it's going to be 81 pi over 2, which doesn't simplify, so the answer is 81 pi over 2.
Okay, so sometimes you're going to have to find volume of solids that have holes in the middle. You basically do the area of the disk of the outside minus the area of the inside, and you have square root of x minus x squared. And the outside function will be square root of x, and the inside function will be x squared. So it makes this little part right here. You're trying to find the volume if that is rotated around the x-axis of this little part. So the way that you would set it up is volume equals pi times the integral of x squared, square root of x squared minus x squared squared. And you do the same thing where you do pi r squared to find the area of the discs. And this just takes you through the process. You simplify it and then you anti-derive it, and when you plug in the numbers, you get 3 pi over 10. Okay, so sometimes you're going to have solids that are rotated around something that is not an axis, like this one, where you're rotating square root of x around y equals -1, and we're going to bound this area by x equals 3. So whenever you do this, you create washers, and the radius of the inside part is going to be the same. So what you would do is you would set it up as volume equals pi times from 0 to 3 of 1 plus square root of x squared minus 1 squared. And this takes you through the process where you simplify these, and then you anti-derive it, and you plug in the numbers, and your final answer should be 4 pi square root of 27 over 3 plus 9 pi over 2.
Finally, you can use the integrals to find volume of areas using cross-sections of a specific shape. You can use triangles, semicircles, but in this case we're going to use a square. And for the process, you're going to plug the square formula to find the area of a square, which is just, you know, the side of a square squared. And what we're going to do is we're going to put this in this. But first, to visualize this, you're going to imagine cross sections of squares in this formula, and to find the side length of the square, you have to do like what we told you before of the top function minus the bottom function to find the length of the side. And to set this problem, we're going to use the functions y equals x squared and y equals square root of x, and they're going to create a form that we're just going to call R, and it's from 0 to 1, and we're going to be using cross sections of squares. And to set this up, we're going to have to use a calculator for this problem just because you're not going to be able to anti-differentiate this easily without using FOIL, and we're just going to type it in the calculator. So it's going to be the integral from 0 to 1 of x, the square root of x, which is your top function, minus x squared, which is your bottom function, squared, because it's the square cross section, so this is your side length, and you're going to square it just like you're finding the area of the square in dx. And then when you type all that into the calculator and say what is the integral from 0 to 1, it's going to give you an approximation, and you're going to have to round it to the first 3 decimal places, and you're going to get it as equals 0.129. Once again, this is Sarah Square,
And we are sure that you are able to master area and volume using integrals and derivatives now.